This model is a bicycle that is self-balancing and it's manipulated by control systems. We have the option to change controllers between 4 different controllers. So now we have the linear quadratic regulator. We can switch between pole placement, PID, or an observer. So for example, we can choose PID or an observer. Right now we are going to try linear quadratic regulator. And also we have the option to insert an input, so it's a perturbation. So right now we have a force that makes the handling turn right. We can also make it turn left, or we can also apply a force to the frame of the bicycle. Okay, let's try with the handles turning right. So if we run this with this configuration, we are going to get to this screen. Okay, it's gonna start compiling, and it will start with a real constant velocity, which gives the bicycle an initial input. Then at 1.1 seconds, the input will be applied. So let's see in action. Okay, in 1.1 seconds, we have the input to the right. We can also change cameras, so we can see it to the front. You'll see it again. So in 1.1 seconds to the right, it will self-balance with the linear quadratic regulator. So to see it more clearly, we can also, for example, we can choose to have the front view. You can also choose the rear view and the superior view. So this way. Okay, so at 1.1 seconds we get the input and it's turning right. Then by the action of the controller, it's stabilized. Okay, we can also have some graphs, so to see how the controller behaves and the inputs. Okay, so we can see here, this is the inclination angle, so it's the frame angle. We have also the velocity. We have the turning angle or the handling angle, its velocity. We have also its input at 1.1 seconds and the controller. So as you can see, it's stabilized at all the points. Okay, to try something different, maybe we can change to PID, and we can change maybe to some different inputs. Okay, if we run this, so let's see, we see the input of the frame. It's a little smaller because it's not directly on the handle. We can also see it slower. We will see 1.1 seconds. See it. You can see it here. So the controller is gonna direct the handles in the direction the bicycle is falling, so it doesn't fall. So with the help of sensors and the position of the angles, the controller will get adjusted. Okay, we can also see the graphs. They are a little different. As you can see, it's another force here, another direction. We have also the velocities. Here is the controller and the input. Okay, we also have the option to change to a different geometry. Okay, we can return to the original conditions, the different geometry. This is different. Okay, here's geometry number 2. As you can see, it's all different colors, and also it has different dimensions. So detail. Let's see first. Slightly different behavior. So to see the different geometry, we can also choose an isometric view. Okay, as you can see, it's larger and it's a total different geometry. Okay, we also have some parameters. So for example, we have the gravity. In the bicycle, we have some contact forces. So in the front wheel, we have all these contact forces. These forces make some friction, so they make the model to be non-linear. We have some tiny friction bolts. Also in the rear wheel. These contact forces actually, if we dive into the model, this model was made in Inventor. So we have, for example, rear wheel. We have some constant velocity. In reality, it would be like a motor, electric motor. It will give some impulse, or it will mean some initial force made by someone riding the bicycle, and the controllers will make it like a safety measure, so he or she don't fall. Okay, so here's the constant velocity. We have some joints, and here are all the contact forces. So as you can see, there are many forces. These forces make the shape of the wheel. Okay, we have all the shapes here, all the joints. Okay, we also have the option to simulate forces inputs in dashboards. So for example, we could apply in real time forces to the handles and forces to the frame. But actually for this, you will need a very powerful computer because of all the simulations that have to be made. Okay, if we get into the controller diagram, we have the feedback loop. We have all the joints that control the bicycle. So for example, here's the inclination angle. That is one of our state variables. We have here also the handle angle. So we have the feedback loop. Here we have all the constants of the different controllers. For example, we have the linear quadratic regulator. When we switch to the pole placement, we have also the constant to the pole placement, the observer, and all of these are calculated on a MATLAB script. So taking in account all the control systems and the shape of the bicycle. So, and also the physical properties like inertia and the weight of the bicycle. Okay. And in the inputs, it's just an input. We can see here, it's an input of 8 Newtons. Okay. And also we have the cameras. And of course the ground.